Hello. Okay, this session will be on adding and subtracting surds. And two important points you have to remember and you should write down. The first one is whenever we add or subtract surds, we have to make sure the surd is written in simplest form. And to explain what that means, I'll just if I have the following surd, the square root of 8, this surd is not in simplest form. And in our first session, we learned how to simplify a surd. With the square root of 8, if I quickly simplified it, I would have 4 times 2. And the reason why I've chosen 4 times 2 is because I know 4 is a perfect square. So if you don't know how to simplify surds, you need to watch the first lesson. So we just separate these. I've got the square root of 4 times the square root of 2. Now I know the square root of 4, because it's a perfect square, the answer is 2. It's a whole number times the square root of 2. And we know that times is just invisible here. Now, the square root of 8, if you put the square root of 8 on your calculator, and if you put 2 square root 2 on your calculator, you will get the same answer. The square root of 8 and 2 times the square root of 2 equals the same thing. They're the same number. It's just that the square root of 8 has been simplified. And we can see the square root of 2 can't be simplified anymore. So when we add or subtract surds, you have to make sure the surd is written in simplest form. Okay, and the last point was like surds can be added when written in simplest form. So like surds, if you remember with algebra, if we had like terms, for example, just clear the page. If I have x plus x, because they're the same and because I know there is an invisible 1 in front of the x's, I can add these two x's together, and 1x plus 1x is simply 2x. And that would be it. But imagine instead of x, I had the square root of 2 plus the square root of 2. Just like with algebra, how many square roots of 2 do you see? Well, there are 2 square roots of 2, so my answer would be 2 square root 2. And just like with algebra, there is an invisible 1 in front of those square roots of 2, and just like going 1x plus 1x is 2x, 1 square root 2 plus 1 square root 2 is 2 of those. And that's how you add surds. And that's what we mean by adding like surds. Just like adding like terms when it comes to algebra, adding like surds means how many of the exact same surd do you see? But you have to make sure the surd is simplified all the way, and then just to make sure there's nothing you'll be missing out on. Okay, so let's try these 3 questions. Have a go first, and then let's see if you've got the right answers. So with the first one, just check our surds. I've got a square root of 2 here and a square root of 2 there. They're the same surd. So how many square root of 2's do I have? In this case, we've got a positive 6 plus 3. Well, 6 plus 3, that is 9. And of course, 9 square root 2. And that's how many we have. And we're done. With number 2, just be careful with your negatives and positives. We can see that we have a negative 3, but let's check our surds. So the square root of 3, and I have another square root of 3 here. They're the same surd or a like surd. So I've got minus 3 plus 4. Well, minus 3 plus 4 is positive 1 square root 3. And of course that 1 can be invisible. So your final answer will just be the square root of 3. And we know that there's 1 that's invisible there. With number 3, I've got a square root of 2 here. Do you see any other square root of 2's in the whole question? That's a square root of 3, so no. But yes, there is 1 here. We know there's an invisible 1 and also a 1 there. So a positive 1 plus 1 gives me 2 square root of 2's. There's 2 of those. And you can cross it off as you go. And here I've got a square root of 3. And just make sure you know to check to the circle to the left if you're confused with negatives. That is saying minus 10 square root of 3's. And because I can't, there are no more surds and no square root of 3's, then it's just simply take away 10 square root of 3. And I can't do anything with that. And that will be your final answer. Okay, question 4. Once again, just start from the beginning and start with the first surd, and that is the square root of 6. Yes, the square root of 6, I can't simplify it anymore, and all these surds in here can't be simplified anymore. So just add how many square root of 6s that we have. Now, if you're confused with negatives and positives, always circle to the left. So that square root of 3 is a positive square root of 3. That's a negative 7 square root 6, positive 8 square root 3, and negative 2 square root 6. Just so you don't make any mistakes with negatives. Alright, and I've got minus 2 square root of 6. Any more square root of 6? Yes, it's here. So minus 2 minus 7. That leaves me with minus 9 square root 6. And you can cross it off to see what's left. And we've got the square root of 3. Do I have any more square root of 3s? Yes, I do. And I know there's a 1 here. So positive 8. So 8 plus 1. That leaves me with positive 9 square root 3. And that would be my final answer. I can't add these surds together because they're different. It's like having x and y. Now with question 5, at this stage we can't add the square root of 12 and the 2 square root 3 together. They're different surds. They've got different numbers under the square root. So at this stage we can't add them. But with the square root of 12, you'll notice that we can actually simplify this further. And maybe we'll get the same surd, which is the square root of 3 in this case. So first, simplify the square root of 12. To simplify this, we know how to do this. A perfect square that's a factor of 12 is 4. And I know 4 times 3 gives me 12. And then the square root of 4, it can be separated, times the square root of 3. Square root of 4 is simply a whole number 2, and the square root of 3 can't go away, can't disappear. And we know there's a times it. Now don't forget we've still got the plus square root 2. I'll bring it down here just to emphasize that. I haven't forgotten that. And now you notice we ended up with the same surd, square root of 3 and the square root of 3. And because they're like surds and then they're the same, we can add them. So I've got 2, it's all positive, so 2 plus 2 is 4, and instead of 4 like x, we have 4 square root of 3, and we're done. Okay, so with this one, once again, let's have a look and see what numbers we have. We've got a whole number 6 here, so that's just a whole number, not a surd. We've got the square root of 6. Can the square root of 6 be simplified any further? No, it can't, so I can leave that there. The square root of 4. Now, the square root of 4, is it a surd? No, it's not, because we know the square root of 4, there is a number times itself twice to give us 4, and that is 2. So the square root of 4 is actually a whole number 2. So I can just do that there. And the square root of 24, this is a surd, but has it been simplified? No, it hasn't. So we have to simplify the square root of 24. And I'll do that now, just to work that out first. So what perfect square multiplied, what's a perfect square that's a factor of 24? Well, I know that 4 times 6 is 24, and I can simplify it. So I'll just simplify it down here. Imagine you had a piece of paper you could work this out on to save some space. So the square root of 4 can be separated times the square root of 6. Just squeeze it in. Now we know the square root of 4 is simply 2. And 2 square root of 6. So finally, the square root of 24 can be written as this, 2 times the square root of 6, and it has been simplified. So I'll just rewrite what I have. Okay, so I just rubbed out the working out for this bit so I had more room. Now, so I know the 2 square root 6 was that square root of 24, and there's my 2, where the square root of 4 was. And now let's see what we can add. Starting with 6, do we have a whole number in this question without the radical sign? Yes, we do. That 2, which was a square root of 4, is now a whole number. And that 2 is, always look to the left, that's a negative 2. So what is 6 minus 2? Well, 6 minus 2 is 4. And I can cross my numbers off. I've used those. I'll change my colour. Okay, so they're being dealt with. Now, I've got the square root of 6 here. I know there's a 1 in front of it. In this question, do we have the square root of 6 anywhere else? Yes, we do. And there's a positive 2 square root 6. So what is positive 1? So what is 1 plus 2? Well, 1 plus 2 is positive 3 square root 6. And that's our final answer. There's nothing else we can add. Please be careful. We can't go 4 plus 3. even though they're whole numbers, the 3 is outside this radical sign. We can't add them together. It's like having 4 plus, instead of 3 square root 6, 4 plus 3x. We can't add 4 plus 3x because that 3 is not on its own. It's actually saying 3 times x, or 3 times a number. And if x was 2, for example, I'd have 3 times 2, which is 6. So it's not really 3, it's actually a different number. So 3 times the square root of 6 gives you a decimal that is not 3. So we stop there.